Hi, this is Eric. We're back again. This is the third video. In the first and second videos, we showed how to create some drawings, how to create the gears, and how to send them to Cura for slicing. As your 3D printer is grinding away, what you probably want to do is try to complete the animation requirements for our project. And earlier we saw our design, and we saw the motion study. This is motion study 2. And if we run this, what we see is that we have a good motion study of all of our parts of our whole machine, and everything is rotating correctly. Now we showed the process of creating a motion study for just the gears. But if you followed that procedure and didn't do anything else for your complete machine, it wouldn't actually run correctly. So what I've done is I've created a motion study 3, and this motion study has the contact groups between the large and medium gear, and between the medium gear and the small gear, and it has the motor, rotary motor that drives the small gear. But if we run it just in its current state, if we say run it doesn't actually work correctly. It doesn't. Nothing really quite seems to be rotating properly. But the step which is missing is that we have to create some rigid groups. And what this particular part of the whole video process is about is to show you how to do that. So we go to our tree of parts here, and we select the large gear. We'll right click it and say add to new rigid group. Okay, and then if we drag down to the bottom, we see a new rigid group was created. I'm going to rename that to say large gear rigid group 6. Okay, and if we go back down to the bottom, we see it selected. We have to hit escape so that it's not selected. Now we can kind of use our mouse wheel, get back up to the top, and say, well, what should be rotating at the same time as the large gear? Well, we know that the table is one thing. So if we click on the table and drag it down and arrow over the large group, we can expand that by clicking. We see that we've got the gear, we've got the table. The other thing which we need to be part of this is the shaft. So if we click on that, drag it down to the bottom, and position it over the large gear, rigid group 6, we see that we've got the gear, the table, and the shaft. Okay, we can minimize, or we can collapse that one. Go back up, and select our medium gear, which is gear 2. Right click, add to a new rigid group. We go back to the bottom. We see that it created new rigid group 7. We're going to rename that to be medium gear rigid group 7. Okay, and then if we come back down, we have to hit escape so that it's not selected. What should be rotating with that medium gear? Well, I would say the shaft of the medium gear is the most important thing. Whoops. Okay, shaft medium gear. We drag it down to medium gear rigid group. We come back down, expand it. We see that the gear and the shaft are there. That's cool. We go back up to the top. We hit escape. We go back to our small gear, right click, add to a new rigid group. Okay, if we come down to the bottom, We see new rigid group 8. Going to rename that, and I'm going to call that small gear rigid group 8. Okay, and what we know is what do we need to have that? Okay, we'll come up. We want the shaft of the small gear to be added to that. We drag it down, and we know that the knob should also be there. Okay, we drag the knob. Okay, so now we have our rigid group set up, and if we're trying to make a really complete model, we could drag the clevis pins in there too, but we don't really need to do that. So if we hit our let's try and expand this this a little bit. Well, okay, we hit the calculate button, and we see that everything is rotating about the way we want. And if we set for loop, and then we say run it, this is too fast. I only want 1x. Okay, there's 1x, and we see that now our complete machine is animating correctly. So this is pretty good. I like it. I think this is exactly what we have been hoping for. This is now a completed animation of our complete machine, and the key step is to create the rigid groups. Now you might expect that your mates that you created when you actually designed the machine would convey that information to the animation software, but you'd be disappointed if you thought that, because it doesn't quite work that way. You might hope that it works that way, and it would seem logical, but the software just simply it needs rigid groups. Okay, well, this is about the end of our videos, the end of our video series. What you can see here is that there's obviously an awful lot of steps and a lot of opportunities for things to go wrong. And I'd say don't feel bad if this seems complicated or you're kind of struggling trying to get your own design to work, because the machine that we're showing here is about the 4th generation of effort. We kept building a lot of parts. We got an idea of how to make it better. We built a lot of parts and found that they didn't quite fit together, or they didn't work, so we created new stuff. And this took about a month of work. I think it's a really smart SolidWorks person could do it in a lot less, but I'm just a student as I create this. So yeah, don't feel bad if this seems complicated. So let's hit stop and minimize this. We can minimize this and try and go back to our steps and try and review what we did. So we created a 2D drawing to constrain the gears so that all they can do is rotate. We added the actual 3D gears. We created an animation to show the gears rotating and meshing, but this was only the gears. Then we set up for 3D printing to print our gears, and then we added some additional elements to the design, which I didn't really show you the design part of that, but designing shafts and base plates and knobs and stuff is something that a typical 3D design SolidWorks person can do. Hopefully, if you need a different video for that, hopefully you can find it elsewhere. And then we created an animation of the complete machine in action. And it really shows the power of SolidWorks to be able to do all of this stuff. I think it's pretty amazing. And, well, I hope you enjoyed the video. I hope it's helpful to you. If this is helpful to you, I hope you will click like and maybe make some comments in the YouTube comments. All right, well, Eric Larson again, signing off from Silicon Valley, home of engineering. All right, see you later.